The alkaline earth metals are chemical elements in the periodic table. They are part of Group 2, located in the second column from the left of the periodic table. The alkaline earth metals include beryllium, B, magnesium, Mg, calcium, Ca, strontium, Sr, barium, Bar, radium, Ra. These elements share some common characteristics. Reactivity: alkaline earth metals are less reactive than alkali metals, group 1 elements, but still more reactive than most other elements. They readily react with water and oxygen. Valence electrons: they have 2 valence electrons in their outermost electron shell. Physical properties: alkaline earth metals are typically shiny, silvery white metals with relatively low densities compared to other metals. Melting and boiling points: they generally have higher melting and boiling points than alkali metals. Ionization energy: the ionization energy of alkaline earth metals is higher than that of alkali metals but lower than that of most other elements. Chemical properties: they form alkaline solutions when they react with water, hence the name alkaline earth. The oxides and hydroxides of these metals are basic. Occurrence: alkaline earth metals are commonly found in the Earth's crust, often as compounds with other elements. These elements have various applications in different industries. For example, magnesium is used in alloys and as a reducing agent, calcium is essential for bones and teeth in living organisms, and barium is used in medical imaging. Radium, due to its radioactivity, has limited practical applications and is more known for its historical significance in early radiotherapy. Let's delve into more detail about alkaline earth metals. Beryllium, B. Beryllium is a relatively rare and lightweight metal. It has a high melting point, and is non-magnetic. This element is named after the mineral beryl. Beryllium is released from the burning of fossil fuels and tobacco. This is a health hazard because it is chemically similar to magnesium, and replaces it in the body, causing damage to cells. However, it has many applications when alloyed with other elements, such as making missiles and satellites. Beryllium and its alloys are used in aerospace components, X-ray windows, and other applications where its lightweight and high strength are advantageous. One chief source of beryllium is beryl, a naturally occurring mineral of beryllium, aluminium, silicon and oxygen. Beryl can take on many different colors depending on the impurities present. Aquamarine is a type of blue beryl gemstone. The presence of iron makes it blue. NASA's James Webb Space Telescope JWST was launched in December 2021. It has been designed to collect data about the solar system, planets around other stars, and the Big Bang with which our universe began. Light from distant stars is collected by an array of gold-plated beryllium mirrors, making the mirrors strong and lightweight. The JWST collected its first images in February 2022. Lithium and beryllium were 2 of the first elements in the universe. They were created in the Big Bang, the huge explosion that started our universe. Magnesium, Mg. Magnesium is a lightweight, silvery white metal. It has a relatively low density, and is a good conductor of electricity. This lightweight metal is very reactive, including with oxygen in the air. When it burns, it produces a bright, white glow that is so intense it can damage the eyes of anyone looking directly at the burning metal. Magnesium is used in flares and fireworks. Plants need sunlight to grow. Chlorophyll, a green-colored compound found in plants, absorbs light energy from the sun, allowing plants to convert carbon dioxide and water into oxygen and sugars in photosynthesis. At the center of each chlorophyll molecule is a magnesium atom. Magnesium is commonly used in the aerospace industry as an alloying agent in aluminium to improve its strength and in various electronic devices. Magnesite is mainly made of magnesium carbonate, used in flooring, cosmetics, and even toothpaste. When heated up strongly, magnesium oxide forms, which is used to line furnaces due to its ability to resist heat. Magnesium carbonate is added to medication to ease heartburn and other stomach ailments. The carbonate reacts with excess acid in the stomach, producing water, magnesium chloride and carbon dioxide gas. The gas can make you burp. Magnesium and calcium were once thought to be the same element. In 1755, Scottish chemist Joseph Black proved they were different, but pure magnesium was only isolated in 1808 by Sir Humphrey Davy. Alloys containing magnesium are both strong and lightweight. For that reason, several of them are used to manufacture high-performance machinery. One such alloy is Mag-Thor, a mixture of magnesium, thorium and many other elements used to build aircraft engines. If magnesium catches fire, hosing it with water would only worsen the flames. Calcium, Ca. Calcium is a soft, gray, alkaline earth metal. It is highly reactive with water and oxygen. This soft metal is the fifth most abundant element in the Earth's crust. As a part of a mineral called hydroxylapatite, it strengthens our bones and teeth. Calcium compounds are also beneficial in industry and construction. For example, calcium oxide is used in cement production, while calcium hydroxide is used for treating sewage. In caves, deposits of calcium carbonate form structures called stalactites and stalagmites. Stalagmites grow up from the ground while stalactites hang up from the roof. Calcium is essential for living organisms, playing a crucial role in bone and teeth formation. It is also used in steel production, as a reducing agent in the extraction of metals from ores, and in the preparation of calcium-based antacids. Calcium compounds are used to reduce acidity in various ways. They are added to tablets that reduce acid-related discomfort in the stomach. Calcium supplements can also boost some plants by making the soil less acidic. Calcium is the most abundant metal in our body. Calcium isn't only needed for strong teeth and bones but also helps our cells work correctly. We get calcium in our body by eating calcium-rich food, including dairy products and nuts. Calcium makes dark orange fireworks. Strontium, Sr. Strontium is a soft, silvery metal. It oxidizes quickly in air and reacts violently with water. This element is named after Strontian, a Scottish village near where its ore, strontianite, was discovered. Strontium has a radioactive isotope named strontium-90. Nuclear accidents, such as the 1986 disaster in Chernobyl, Ukraine, have released a large amount of strontium-90 into the atmosphere. Compounds of the alkaline elements are used to produce colorful flames. Strontium compounds provide bright crimson found in flares and fireworks. Barium, Bar. Barium is a soft, silvery metal that oxidizes rapidly in air. Discovered in 1808 by Sir Humphrey Davy, the name of this highly reactive element comes from the Greek word baris, meaning heavy. Interestingly, it is not barium itself that is heavy but the minerals, such as barite, in which it is found. When it burns, it produces a green flare. Barium compounds are used to produce various chemicals, glass, and ceramics. In a medical test called the barium meal, a patient swallows a meal of barium sulfate, a harmless compound that passes through the digestive tract. This allows a patient's digestive organs, highlighted by the barium compound, to be examined using an X-ray photograph. Radium, Ra. A very radioactive element, radium gets its name from the Latin word radius, meaning ray. Radium glows in the dark due to its radioactivity. In the early 20th century, radium compounds were used in medicines because people believed that radium cured diseases. However, it was phased out when people who took these medicines became unwell. Formerly known as pitchblende, uraninite is mostly uranium oxide and other elements that form as the uranium decays. Polish-born French scientist Marie discovered radium and polonium by processing massive amounts of uraninite. An isotope of radium, radium-226, was used for luminous watches. The paints became popular in the 1920s, long before their health risk was fully understood. Many people, especially women, who worked with these paints became sick and even died as a result of exposure to radium. 1898 Marie Curie discovered radium and polonium, sharing credit for the former with her husband, Pierre Curie. She received the Nobel Prize in Chemistry in 1911 for these discoveries, becoming the first woman to win a Nobel Prize and remains the only woman to receive two. Common characteristics. 2 valence electrons. All alkaline earth metals have 2 electrons in their outermost electron shell. Reactivity. They are less reactive than alkali metals but still quite reactive, readily forming compounds with other elements. Ionization energy. Alkaline earth metals have higher ionization energies than alkali metals but are lower than most other elements. Alkaline solutions. When these metals react with water, they form alkaline solutions. Basic oxides. The oxides of alkaline earth metals are basic. In summary, alkaline earth metals share common characteristics but exhibit variations in their properties and applications. They play essential roles in various industries and have biological significance in living organisms. Remember to subscribe to our channel. Bye.